All right, the ambiguous case. When do you get two possible answers when using law of signs? You get two possible answers in the instance of the ambiguous case. The ambiguous case happens when there is side-side angle on a triangle. Okay, meaning we can form two different triangles with this information. Right? So I'll try to fit in a sketch here. We have this side length and this angle measure, right? Those are given. And then we have one more side length that we know. Well, that side length could go here or it could go here. I know it's a rough sketch, but those side lengths are the same. With side-side angle, you can form two different triangles. So when using law of signs, you don't necessarily know which of those two triangles you're forming, but you should know that two different triangles are possible. And that's all I want you to know about the ambiguous case. I want you to know it's out there, but we won't be solving for two different triangles. We'll just know that it is a possibility. Okay? All right. Then let's try this application problem. The map shows the path a pilot flew between Omaha and Chicago in order to avoid a thunderstorm. How much longer is the route than the direct route? So we need to figure out this route here, right? Well, I'm going to label this X and this Y. And we want to find X and Y, those values, right? Well, we can find this angle right here pretty easily. We know two angles in a triangle, so 180 minus 113 minus 22 leaves us with 45 degrees for that angle. Now I have an angle and a side opposite, angle and a side opposite. So I'm going to set this up. Sine 22 over x equals sine 113 over 471, right? So I want to solve for x. I'm going to cross multiply. So I get 471 sine 22 equals x sine 113. Divide by sine 113. And I get x equals 471 sine 22 over sine 113. I'm going to plug all that in my calculator, and when I do, I get 191.68 miles, right? So that's this distance right here for x. I'm going to have to do the same thing to get the y value. So sine 113 over 471 equals sine 45 over y. Again, I would cross multiply to get y by itself. And divide by sine 113. Right? And when I do all that, I plug all that in my calculator, I get y is 361.81 miles. Right? So we know x and y. We want to know how much longer this route is. So I'm going to add these up. I'm going to do 361.81 plus 191.68. And I'm going to take away that 471, the amount it takes if you go directly there. Do that, I get 82.44 miles longer. Great. All right, let's do this last example. So with law of signs, you can find area of a triangle, and we have an equation for area of a triangle with law of signs. That equation is 1/2 a times b sine c. Using the sine ratio of the angle between the two known sides, create a height for the triangle. Try it out by finding the area of RST. So to calculate this, we can find the area here with this equation, 1/2 AB sine C, right? We have two sides, we have the angle in between. So this is like my A, this is my B, and this is my angle C, right? It's the angle in between those two sides. So the area would be 1/2 2.8 times 2.8 times sine 135. And if I plug that in my calculator, I get the area as 2.77 centimeters squared. Great. Well, let's go back and just look at this last problem. Want to re-go over this one in case you're curious kind of how this law of sines comes to be. All right, like I said, it'd come back to this, how the law of sines equation, where it comes from. So let's just follow these steps to construct the law of sines. So first we're going to construct the altitude from angle A. So remember, an altitude goes from a vertex and it goes down to the opposite side, forming a right angle. I'm going to label that side H. Now write a trig ratio for angle B and angle C. Well, from angle B, H is my opposite side, C is my hypotenuse, so I'd say sine of B equals H over C. Can do the same thing from angle C. H is again opposite, B is hypotenuse, so sine of C equals H over B. Now, I want to get H by itself in both these cases, so for the top one, I'm going to multiply by C, which gets me C sine B equals H, and multiply by B, and I get B sine C equals H, right? So now I have both these equations equal to H. Use substitution to write a proportion. Well, if both equations equal the same thing, and they do in this case because they both equal H, I can set them equal to each other. So C sine B equals B sine C. I want to get them in proportion form, so I'm going to divide both sides by C. That cancels this sign out, so I have sine B equals B sine C, or sorry, all over C, right? And then I'm going to divide by B on both sides, and that cancels that out. So I have sine B over B equals sine C over C, right? Great.